Bismillahirrahmanirrahim. Welcome to another lecture on operations planning and scheduling. And today we are going to start module 3, that is operations scheduling. And in this module, we will be discussing how actually the plan that was made using master production scheduling concepts is put into action. So we will be discussing the scheduling for different production environments. We will be starting with job shops. Actually, we should have started with project scheduling, but that is one of your courses in the first semester. So I hope you will be discussing there how project scheduling is done. So that is why we are going to start with job shop scheduling. So that's why we are not going to discuss project scheduling here, and we are going to start with job shop scheduling. So at the end of this lecture, you should be able to understand what is a job shop. In fact, we have already discussed that in the very first lecture. So we will review those basics and we will build on those basics about job shops. One of the important documents that is used in production of any product that is used on the production floor is a routing sheet. So that is not specific to job shops, that is used in batch production, in mass production as well. So that may have different names. It is called routing sheet or route sheet, or it may have some similar names. So we will see what that routing sheet is and what's its role in production activity control. There are basically two types of scheduling in job shops. We are having forward scheduling and we are having backward scheduling. In fact, these two types of scheduling is there in the projects as well, but it has different names there in a project process. Then we will discuss different priority rules for a job shop, and we will be spending more time on this, how we can actually prioritize the jobs at a certain workstation once there are more than one jobs to be processed on the same workstation. And our goal here in job shops is to reduce the manufacturing lead time, and we will focus on two simple methods. They are operations overlapping and operations splitting, and they are used to reduce the manufacturing lead time. And again, these two concepts are applicable to batch process as well as to line production. So many concepts that we will discuss today are applicable to our discussions in the following lectures. First, we will discuss some basic concepts and terminology. Just as a recall that we have discussed actually the planning phases in a manufacturing organization, we have discussed how the production plan is made and how that broader level plan is converted into end product plan, the plan for end products, that is master production schedule, and how that plan is converted into the plan for raw materials and components, and that is something that we have discussed in detail. Today we are going to start discussion on production activity control. So how the plan is put into action. So it is called production activity control, shop floor control, shop floor scheduling. So it has different names. So we have seen this figure repeatedly. So we have discussed the production plan, the master production scheduling, material requirements planning, and we are going to focus production activity control. That has a very short planning horizon. It is done practically on daily basis, and it is reviewed on daily basis. So level of detail is very high. We are discussing each and every machine that is involved in the production, each and every step that is required to make the product. So it is quite detailed, and this discussion will be further. We will be going into further details of the discussion as we will discuss other production systems like batch and mass production. And you will notice many similarities between between scheduling of different production systems. So what is jobbing or job shop? It is an organization in which similar equipment is organized by function, and each job follows a distinct routing through the shop. Equipment is organized by function, so that is called functional layout. And each job follows a distinct routing. So each job has different part to follow. There is at least some difference. And the time spent at different workstations is generally different from job to job. Another definition is a type of manufacturing process used to produce items to each customer's specifications. So basically, job shop is an example of make to order production system. Production operations are designed to handle a wide range of product designs and are performed at fixed plant location using general purpose equipment. So again, the equipment is general purpose and it is organized by function. And you could see that there are a wide range of product designs. That means the variety is high and volume is low. So this is the definition, in fact, two definitions of a jobbing or a job shop process. So we will further go into detail of what is meant by a functional layout and what is meant by routing. So this type of production system, job shop or jobbing, is sometimes also called intermittent production. Intermittent production because we are moving from one order to the other order, and the nature of product is same, but the routing and the time spent on each order and the sequence that is different. What are the features of a job shop or a jobbing process? Responsibility for making the product is normally given to skilled persons who decide how best to make it. So this is something common in jobbing and project process. Skill level required is generally high. Same type of machines are grouped together, so that is called functional layout. Workers move products depending upon needed processes. So sequence and routing is to be planned carefully and it is to be managed carefully as well. Special type of product is made and generally the order size is small, so we are having low volume production. Examples that we have already seen are purpose-built tooling, dies and molds, and for example, the manufacturing of some special purpose car or the car that is not made in bulk, just like Formula One car. So the dies and molds, so each die or mold is different than the other, but the process to make a die or mold is very similar. So there is generally some machining involved. You may need milling machine, for example. There is some grinding that is required. Some lathe work might be required. So there are some general purpose machines that are required to make any die and mold, but depending upon the size of the mold, the number of cavities and some other features, if someone of you is from mechanical background, he can understand it better. So depending upon these factors, the time spent by each mold on different machines will be different. So that is an example of a jobbing process. The shop or the organization that makes molds and dies is an example of a job shop. We already saw this example, the artificial joint making. So of course, these joints are not made in bulk. They depend upon the physical features of the patient, and it is made as per order. And of course, this is not made in big quantity, and some general common processes are required in order to make such joints. Another example that we saw was the making boards of a composite material. So this is also highly skilled process. Composite material manufacturing is requiring a lot of craftsmanship, and it takes a lot of time to make a board of a composite material. Again, this is not something that is for general use. The people who require it are actually ordering it to be made. So if you are aware of the process to make composite products, so you need some equipment to spray the matrix that is used in the composite material. And again, there is some simple hand equipment, hand tools are required to make products using composites. So the technology required is not too advanced, but it needs a lot of skill. The order size is small, but each board will be different from the other, or you will be making the boards of the same design in very small number or the quantity. But the steps required to make any board will be very similar. For example, making drones for a special requirement also requires a lot of craftsmanship. The steps required are same, but depending upon the design and application, the time spent on a specific design will vary. So these are just few examples that we had already seen, but just to give you some visualization of how a job shop actually works and what are its features. So the type of layout used in a job shop is a functional layout is a facility configuration in which operations of similar nature or function are grouped together. So operations of similar nature or function are grouped together. So an organizational structure based on departmental specialty. For example, in the case of a mechanical shop, we may have saws grouped together, lathes grouped together, the milling machines grouped together, the heat treatment uh, furnaces grouped together, presses grouped together. So it is also called job shop layout or process layout. So here is the example. So you could see that there is a separate department or separate grouping of the lathe machines. For example, we are having around 10 lathes and 4 millings grouped together. Different drilling machines are grouped together. Grinding machines are grouped together. Painting department is separate, and we have an assembly department. So this is a functional layout. And each product that we are making will be machined on these machines. But the path that it will follow and the time it will spend on each machine or in each department will vary. For example, one product may follow this path and the other may follow this path. So path varies slightly and practically depending upon the nature of the product, the features of the product, the time spent in each department will also vary, but we are making actually the same family of product, dies and molds, boards or whatever, the family of the product is the same, but depending upon the design, size, and features, the path and time will vary. So there are 5 components of a manufacturing lead time. So for example, in this case, if there are 4 workstations, so first the order will be released. And then there are 5 elements of manufacturing lead time. So we are having queue, we are then having setup, run, and wait. And finally, move. So queue is actually the raw material or semi-finished product waiting to be processed on the next process. Setup time is actually required to actually set up the machine for the new lot of the product. So that is the time required to shift from making product A to making product B. So that is preparing the machine or the equipment from one type of product to the other type of product. So that time is setup time. Run time is the time actually required to perform the manufacturing process. So that is operation time or processing time. And waiting time is after this process has completed its operation, then before being shifted to the next process, the product or the semi-finished part waits. So that is the waiting time. And moving or move time is actually required to move the product or transport the product from one workstation to the next. And then that sequence repeats. So we are having a queue, setup, run, wait, move, and so on. And this is actually, these two are the operation related times. So the time required to set up the machine and time required to perform the operation, and the rest are not operation time. So they are called inter-operation or inter-operational times. So let's formally define these. So manufacturing lead time is the time normally required to produce an item in a typical lot quantity. So this is important point that this is the time required to make a certain quantity of a product. So queue time is the amount of time the job is waiting at a work center before operation begins. Setup time is the time required to prepare the work center for operation. Runtime is the time needed to run the order through the operation. So that is sometime called the processing time or the operation time. So that is the actual time being spent on the machine. And in terms of lean manufacturing, this is the only element of value adding time. The rest of the four are actually non-value adding times. Wait time is the amount of time the job is at the work center before being moved to the next work center. And move time is the transit time between work centers. In some books, you will find the word wait time for both the queue time and wait time. So they are treated as one element of time. And both are called wait time, whether the wait is before an operation is performed or after an operation has been performed. So I have a question, and it might be very simple for some of you. Which elements of the manufacturing lead time typically consume the largest amount of time? Okay, this is a typical answer that this is the run time, but actually this is the waiting time. The queue and wait actually take most of the time out of the manufacturing lead time. And even more surprising for you based on your answer of runtime is that queue and wait take around 85 to 95% of the total lead time. So the queue time and wait time, or we can call both of them to be the waiting time, they take around 85 to 95% of the total lead time. I can prove it. I don't have time for it, but during question answer session, I might show you some examples of it. And even in best class organizations, this is around 95%. This is for the ideal organization that they're spending 5% time and even less than 5% time on runtime, and the rest of 95% is on queue and wait. So we will come back to this point if it is something of interest for you. So what is a work center? So I'm just discussing the terminology that was there in the definition of a job shop or some related terms to the job shop. So another one is work center. Specific production area consisting of one or more people and or machines with similar capabilities that can be considered as one unit for purposes of capacity requirements planning and detailed scheduling. So it could be at least one machine or one person, or it might be a combination of course, 1% and one machine if it is, if the machine is, of course, to be operated by the operator. And it could be more than one person and one machine. So for example, in the example that we saw, if there are two milling machines, so that is one work center that has two machines. So we can calculate the capacity of the milling department. And that will be the capacity of that work center. So work center is the resource where the routing operation is performed. Or you could say that this is where we are talking about the runtime. So that is on some work center. So runtime relates to some work center. So that could be machining time or time for heat treatment or whatever is the operation, or it could be manual assembly or some other operation. Often more than one operation is performed at a work center. So it is quite possible that we are having more than one operations at one work center. Now, very important document with respect to job shops as well as other types of production systems is a routing sheet, and it has some other names as well. So information detailing the method of manufacture of a particular item. Now, this is not the method with respect to technical point of view, but this is actually the sequence of operations. So it includes the operations to be performed, the sequence of operations, the various work centers involved, and the standards for setup and run. So basically, it tells what machines will be used to make the certain product, what operations will be performed on each machine, what will be the sequence of those operations, and what is the time that should be spent to make that product at each of the machines. In some companies, the routing also includes information on tooling, operator skill level, inspection operations, and testing requirements, and so on. So it has different formats. This definition was from Epic's dictionary as well. So here is a simple example of a routing sheet. So you could see the name of the product. So it is 1501-001. So that is the product code. The name of the product is 1/4 horsepower sump pump. The lot size is 10, and the times mentioned in this routing sheet is in hours. And you could see the sequence of work centers that will be used to make this pump. The operations that will be performed at each work center. So you could see that 2 operations are performed at work center A100, and 3 operations are performed at work center G220, and so on. And then you could have some details about the process or process instructions. So for example, at first work center, you have to perform grinding, and then at the same work center, the deburring is to be performed. And then you could see the other process instructions as well. Then there is setup time. So you could see there is setup time for some of the operations, but there is no setup time for other operations. And this very important is the run time, or the time required to operation at that work center. You could also see the number of resources. So this could be number of machines or number of workers at that workstation. And then there could be other information like scrap percentage, efficiency, and we could have utilization as well. So we will be defining this terminology in the next lecture. So what is actually utilization, what is efficiency, and why do we incorporate the scrap factor? So this is another example, and we will make some small calculations based on this routing sheet as well. So the part name is gear shaft. This is the part number, and you could see the drawing number, and this format is much simpler than the previous example. So you could see the numbering of the operation, the number of the work center on which that operation will be performed, the setup time in hours, and run time per piece. So you could see that here in fact, that is the example that we'll see later. So this time, however, can be per piece, or this can be per lot as well. So you have to be careful while making calculations that the runtime given is per piece or per lot or batch. And then there is some description of the operation. So first operation is turning, the second is milling, then drilling, grinding, and the last operation is simply moving the product to the stores or inventory. So setup time and runtime are considered as operational time, and queue, wait, and move are inter-operational time. So these are called operational time because they are directly involved in production. They are considered as necessary time elements. So a very simple question, assuming an 8-hour shift per day, how long will it take to process 20 gear shafts? And sorry for the spelling mistake. So for the sake of simplicity, ignore queue, wait, and move time. Or in other words, what is the operational time that is required to make 20 gear shafts? So for operation 10, it will be setup time 1.5 plus run time. So run time per piece is 0.20 hours. So multiplied by 20. So we will have 5.5 hours. Similarly, for operation 20, setup time plus run time per lot. So again, lot size is 20. So 20 into 0.25, that is the run time per piece. And of course, we are adding the setup time. Similarly, for operation 30, the setup time is 0.30 plus 20 into run time per piece. So 3 plus 20 into 0.05. And similarly, for operation 40, that is the setup time plus 20 into 0.1. So that is 2.45. So total time turns out to be 14.75 hours or approximately 2 days. We are having 8-hour shift per day. But again, that this is the minimum time required to make a batch or lot of 20 shafts. So we are actually in technical terms, we can say that we are assuming 100% efficiency. Even the time spent on these machine might be greater than this. So we are assuming 100% efficiency and we are assuming 100% utilization as well. So we will define these two terms in the next lecture, but efficiency in simple words relates to the speed of the process, and utilization about the uptime, how much time the machine is being utilized. So we are assuming ideal efficiency and ideal utilization. And of course, we are not considering the queue, wait, and move time. So actual time will be much greater than this. So looking at the ratio of that 85 to 90% non-value adding time. So actually, the total time might be something 4 or 5 times greater than this because of the queue, wait, and move time.